All right, in this question, we are asked to factor the following polynomials. Make sure to give it a try yourself before you watch the solution video. Let's start by taking up part A together. Looking at part A, there's the number part, there's the x's, and then there's the y's. Look at them separately. So first we need to find the greatest common factor. Well, since they're both negative in terms of the numbers, I can take out a negative. What can I take out that's in common between both 4 and 10? What goes into both 4 and 10? Well, 2 goes into 4 and 2 goes into 10, so I can take that out, and that's the biggest number I can take out. Now for my x's, well, they both have an x squared, so it's fair for me to take out an x squared. They can both give up an x squared. How about the y's? Well, the first one only has a y, and the second one has a y squared. Well, I can't be greedy and take out a y squared because this first term can't give up a y squared. It can only give up a y. So y is the greatest common factor for that y part. Step 2, we're going to take our polynomial and we're going to divide every single term by the GCF, negative 2x squared y. Okay, negative and negative, that makes a positive. 4 divided by 2 is 2. X squared divided by x squared, that's gone, it's just a 1. Y divided by y, again, that's gone, that's just a 1, so I don't have to write that. Next up, we have a negative 10 divided by negative 2. Two negatives, again, make a positive. 10 divided by 2, that's 5. X squared divided by x squared, that's gone. Y squared divided by y, ooh, there's one y left over this time. So now we have a GCF of negative 2x squared y, and what's left over is 2 plus 5y. So we can rewrite this polynomial now. This guy is going to be the GCF times what's left over after you divide it by the GCF. And that is the factored form of that polynomial. You can always multiply it through to check your answer. Moving on to part B. So part B, again, number parts, x's, y's, and your a's. You have to treat them separately. So I'm going to pause the video at this point. Go ahead and find out what the GCF is. So hopefully you were able to get that the greatest common factor is negative 5xya. That's the greediest you can be while still taking the same amount out of every single one of these three terms. Next up, let's divide everything by this GCF. So all three terms we need to divide by the GCF of negative 5xya. Let's see what's left over. In the first term, negative 5, they divide out into a 1. X squared and the x, well, one of the x's is still left over. Y divided by y, that becomes a 1. A divided by a, that becomes a 1. So we're just left with x for the first term. Now for the second one, we have 10 divided by negative 5. Positive, negative, they clash. 10 divided by 5 is 2. The x squared, same thing, there's one x left over. The y squared, same thing, there's one y left over. And then the a's, they divide out into a 1, so we don't have to write that. Third term, negative 5 divided by negative 5 is positive 1. The x divides out into a 1. Y's, they divide out into a 1. A's, they divide into a 1. So now we see that we have a GCF and what's left over after we divided the GCF. So we can rewrite this whole second polynomial into the GCF times, in brackets, what's left over after we divided by the GCF. And that is the factored polynomial. Finally, part C. We have the numbers, we have the x's, we have the y's, and we also have this little z. So again, I'm going to pause the video at this point. I want you to find the greatest common factor for part C. So it turns out that the greatest common factor is only the number 3, because 3 goes into 6, negative 3, and 9. Since the first number is positive, we're just going to take out positive 3, not negative 3. How about the variables? How come there's no variables? Well, if you look at the x's, this last term doesn't have an x, so I can't take out an x. How about the y's? Again, this last term doesn't have a y, so I can't take out the y's. How about the z? Well, these first two terms don't have z's or z's, so I can't take them out either. So there's no variable that's in common between all three terms. So the GCF is only the number 3. Now we are going to take every single one of these terms, so there's 3 of them, and we want to divide each one by the GCF, which is positive 3. Okay, first one, 6 divided by 3, that's 2. And there's no variables to divide, so I'm just going to copy out my remaining variables. Second term, negative 3 divided by positive 3 is negative 1. And again, just left with the x and the y. Third term, 9 divided by 3 is positive 3. And I just have a z left over, or a z left over. So now we see that the GCF is 3, and this is what you have left after you divided the 3. So we can rewrite this polynomial as 3, and then in brackets, everything that's left over after we divided out the 3. And this, my friend, is the factored form.